Hello, everybody. Um, my name is Navid Nayeri, and I'm the coordinator of the Floatech project. Unfortunately, we have some technical issues with a computer which just crashed, and this leads us to the problem that we will start 15 minutes later. So we have a delay of 15 minutes. I'm very sorry for that, but I hope you have understanding for this issue because it's very complex setup with hybrid and transmitting per YouTube. So we just had a last minute crash and we have to set it up again. So be patient, meet you in 10 to 15 minutes. Thank you.
Can you hear us? Hello?
Okay. Hello again. It's me, Navid Nayeri, the coordinator of the Floatech project. I'm very sorry for the delay. We had some issues with floating IT, and now we've switched to fixed IT, and now it seems to be working. I'm very happy to see so many people attending here in person and also online. And it's a very wide spectrum of participants. So we have some students from our lectures in design and simulation of wind turbines, and also representatives from EU policy makers and a lot of scientists and so on, and engineers from companies. So that's a very nice mixture. And as I said, I'm the coordinator of this project. I'm very privileged to have this project, to have initiated this project. And today we will show what is the outcome of the project. So we have some nice items in the agenda. We will have EU policymaker giving input from the perspective of the EU. And then we will give a short introduction into the Floatech project that will be carried out by myself. And then we will have 3 speakers who show the major outcomes of the project. Then we will have a break, a short break, probably a bit shorter than expected or planned. And then we will continue with the plenum and discussion on the topic of the future of floating wind energy. And today the event will be moderated by Ines Martonelli. And so I will give her now the floor for introducing the next speaker. Thank you very much.
Good morning, everyone, on site and online. I know we're expecting a lot of people online, so thank you for your patience here as well. My name is Ines Martorell. I work at Eurovia. We're partners of the Floatech project, in charge of the work package communication and dissemination and exploitation of the results. Welcome to the final event of Floatech. We are very pleased to introduce today the EU policy officer from on wind energy and research and innovation from the European Commission and from the Directorate General RTD. Please welcome Enrico De Giorgis, and he's online. So thank you, warm welcome to him. Thank you. Can you hear? Yes, perfect. Thank you.
Good morning, everyone. I hope you can hear me well. Good morning from Brussels. I would like to be there with you as possible stories. So, everything is news, and I hope you can see my slides. And offshore and around 16 gigawatt for installed offshore. New installed capacity in 2022 was 16.2 gigawatt. Again, with a majority onshore and 1.2 gigawatt offshore, with an increase of 47% compared to the previous year. Total electricity output from wind last year was 412 terawatt hours, which represents 16% of the national year of the EU electricity demand. Figures on floating offshore, they're not on the slide, but the contribution so far is minor. The commercial installed capacity is 27 megawatt, and of course, then there are some other projects which are more at the level of pilot projects or demonstrators. Try to move to the next slide. Okay. I think it's always interesting to remind ourselves a bit how the targets at EU level have evolved for wind energy in general and offshore. So in 2020, the Commission published a EU offshore strategy, and there the target was 50 gigawatt by 2030 for offshore installed capacity. And then with the Fit for 55 package in July 21, the target, which is here, the overall target for wind was 469. And then the war in Ukraine came, so we needed to push even more on renewables and wind, of course. So in May 2020, the target was increased up to 510 gigawatt by 2030, which would mean that there is a need to install 38 gigawatt per year over the period from now to 2030. And as I said in my previous slide, what happened last year was 16 gigawatt. So we have to more than double what we installed. And of course, I have now an echo. I don't know if something has changed. It's a bit difficult for me to speak like this, but I'm going to continue.
Yeah, you can continue. We hear you.
Okay, sorry for, there is a delay in okay, sorry. So going through the recent new policy and legislative developments, there is a lot going on. There has been a lot of work done. One of the main legislative instrument which has been recently renewed is the Renewable Energy Directive. It entered into force only 10 days ago, a bit more than 10 days ago, it was the 10th of November, and there for the wind sector. So in this period of time between 29 and 2022, where the funds under the main work, the framework program for research and innovation went. So these are data covering the framework program 7, Horizon 2020, and that's it. And you see here the area. I again have an echo. So the main area where funding has been spent are offshore technologies, offshore wind, and research innovation on new materials and components. These are the main areas. And I think this is interesting also for the audience today to see how focus has been already put since several years on floating wind. And if we go to the next slide, we can have a bit more details. Yep.
Yes, could you please take out your headset because the echo comes from YouTube. So if you take out your headset, normally you won't have the echo anymore.
Okay, so but I just closed my YouTube thing. Then, sorry.
Thank you.
Give me a second. Is it okay right now?
Yes.
Can you see my screen?
Yes.
Can you hear me?
Yes.
I cannot hear you.
Can you hear me?
Can you hear me?
Yes.
Okay, so I understand I can continue. I hope you can hear me. So I move on to the next slide, where I present what is going to happen in the next year. So the work program for 2025 under Horizon Europe and for the following years. So the step are now the adoption of the strategic plan for 2025-2027, which is going to be adopted in early next year. And then the work will start to define the future Horizon Europe work programs. There will be an amendment of the work program already adopted for 2023-2024, just to adapt for all urgent needs and ensure continuity of some recurrent actions. And then there is going to be a full work program for 2025. But we have to take into account that there is going to be European elections next year, so a new College of Commissioners will take office by the end of 2024. So we'll have to see with the possible new political priorities, and that's why the work on the practically adapted according to these possible new political priorities. Of course, for the definition of the work program 2025 and the topics to be covered there, inputs for the projects are welcome and needed. So we really look forward to hear from projects like yours, Floatech, what possible further needs in the area that you have covered could be. As an input for the definition of the future work program, of course, we are going to also work with the EDIC wind that I mentioned and the implementation working group on wind. Here on these slides I put, but this is more for the slides will be, I think, shared, so maybe it's more for you if you're interested to have a look. What are the projects currently ongoing under Cluster 5 of Horizon Europe in the wind area, and what is coming. Here I think it's interesting to mention this topic, which has projects recently started, which are in the area of floating wind in different basins, and so we have three projects, now recently started in this area, and then these are the other topics. You can see it's just also to have a feeling of what the priorities have been. So this is on materials, recycling, circularity, and there are three projects ongoing, especially focused on recycling of blades. And then I'm not going to comment all of this, but I think what is still interesting to be mentioned are the upcoming calls, which are going to open next year in September. And one is going to be on the minimization of environmental and optimization of socio-economic impacts in the deployment, operation, and decommission of offshore wind farms. So focus on offshore, which might cover floating as well. And then another one on demonstrations of innovative floating wind concepts. So through this you can see how the focus on floating, and there is an interest to develop further this technology is there. So with this, I thank you very much. I hope you could hear me well, and I look forward to the continuation of the discussion. Thanks a lot.
Thank you very much for your presentation and for all the insight on figures, targets, EU policy regulations, and of course the work plan that is coming and on Horizon Europe. So now you can follow the conference on YouTube, and we'll kindly just ask you to close the Teams. Thank you. I will now give the floor to Robert de Luna. Oh no, sorry, Christian Lafille, sorry. So Navid Nayeri, to explain to you Floatech in the context, so brief presentation of why Floatech.
Yeah, thank you. Let's see if we have the right slides. Okay, so yeah, hello again, it's me, Navid Nayeri, coordinator of the Floatech project, and I will give a short introduction of the Floatech project. And so as we all know, probably the interest in floating offshore wind energy production has increased a lot during the last years. And this transition from fixed bottom onshore or fixed bottom offshore to floating structures has opened a lot of more parameters and design spaces. So there are more challenges, physical challenges within the offshore environment. And that needs new devices, new technologies, new approaches, new methods to simulate the interaction between all the involved physics, and including also control technology and materials and so on. So many new aspects have to be addressed, and that's why we initiated in early 2020 this proposal for the Floatech project. And our consortium consists of four academic partners from 4 European countries. And these include École Centrale de Nantes in France, TU Delft in the Netherlands, University of Firenze in Italy, and TU Berlin, which is here, and where we are the coordinator. And we have also industrial partners involved, like BW Ideol, Sea Power, which is a mixture of public and company entity, and a startup called Next Ocean, and also Saipem as a big stakeholder within the offshore technology, and Euronovia as our partner for communication and dissemination. The project is funded by Horizon 2020, and the overall budget is 4 million euros, and it started in January 2021 and ends in this month. So, and that's why we have this final event. The objectives of the project are to maturate the technology relevant for the floating wind energy by developing a design and simulation environment which allows to take into account these complex interactions of the involved physics like aerodynamics, hydrodynamics, structures, aeroelastics, and control. And this design environment should be, of course, industrial level, so it should be able to simulate many parameters within a short time. So it should be usable by industry. And then we developed 2 control technologies for floating offshore wind turbines, because we can now, with the available degree of freedom of our floating structures, we can also use new methods for controlling the wind turbine. And you will see how these technologies have performed within the project. And the primary goal of this overall project is, of course, we want to make floating offshore wind energy more attractive in an economic manner. We want to reduce the levelized cost of energy of floating offshore. It's still very expensive, and of course it should be less expensive in the future. So our approach is set up through 7 work packages, and which are distributed within 3 actions. Action 1 includes the simulation technology, which contains 2 work packages. The first work package is the development of Q-blade ocean. The second work package is the quantification of uncertainty and the reduction gained through this new device, this new simulation tool. The second work package is addressing the new control technology, the smart control, and it has 2 work packages. Work package 3 addresses the feed-forward wave-based method. So where we try to take into account the approaching surface waves of the ocean and take them into account in the control of in the operation of the wind turbine. And the other work package 4 addresses the active wake mixing. So we want to enhance the mixing in the wake of the wind turbines such that in a wind park you can create more wind energy. That's action 2. And action 3 is addressing the economic impact. So we are not looking only at what is possible, fancy technology. We want also to see how this fancy technology reduces, hopefully, the costs of the overall concepts. And yeah, we are in a very lucky position that our consortium will continue the collaboration within the next project, also financed by the European Union. And this project is called Float Farm. So the name already indicates that we are now moving from individual turbines or just 2 turbines to a bigger context of floating offshore wind farms. And We have increased the number of participants, of partners to 16, and also the number of countries to 8 European countries. And and the coordination will be carried out by Joe Severin, again from TU Berlin. So that was a very brief overview of the project, and you have also these nice flyers which again summarize the project. And I will now give over to the next presenter. Thank you very much.
Thank you, Navid. Thank you very much. So one of the main objectives today is to present the outcomes of Floatech. The partners, the team has been working for 3 years, so we have 3 main outcomes. So first, a warm welcome to Robert Berens de Luna. So Robert, sorry for that. Robert works as a project manager at the Floatech project, and he holds a master's degree in engineering, and he's working currently as a PhD candidate specializing in floating offshore wind. And he'll be presenting with Guillaume Ducrozet, who's a full professor at Ocean Engineering School at École Centrale de Nantes, and he's the deputy head of the LHEA laboratory. Thank you, Robert.
Thank you, Ines. Okay. The slides seem to be a little corrupt, unfortunately, with the format. But I think we can work through those small difficulties, one of the minor ones of today. So thanks, Ines, for the introduction. Thanks, Navid, for the overview of Floatech. I have the pleasure to present one of the major outcomes of Floatech, which is part of Action 1. So this is part of the simulation frameworks and simulation tools that we have been developing and enhancing throughout this project. The small introduction is that, well, if you don't know Cubeblade yet, I will basically give you a small introduction to it, what it has been before Floatech arrived. Then in the second part, I'll just talk you through what we have been developing and what has been achieved within the last couple of years. And at the end, I'll provide a short overview of the publications and dissemination actions that we took part in. So Cubeblade is a wind turbine simulation tool for load simulation in time. It has been under development at the Technical University of Berlin since 2010. And it has 2 different aerodynamic solvers, one of which we are quite proud of is the state-of-the-art beating lifting line-free vortex wake method that allows you to resolve the wake dynamics explicitly. And we have also quite advanced structural simulation solver in there, which is based on the Project Chrono multiphysics engines, in case that tells you something. Then we have interfaced a couple of different controller designs, like the bladed controller, the Hawk 2 controller, but also the TU Berlin, its own controller, of course. And since all this development doesn't really mean a lot if it's not validated properly or verified against experiments, we've also done that against Hawk 2, against NREL's OpenFast, the Mexico experiments, and so on. Now, the objective within Floatech was to bring this, especially the aerodynamic capabilities, to the floating offshore domain, and thereby increase the aerodynamic fidelity for those kinds of simulations, because now, with the additional degrees of freedom that a floating offshore wind turbine has, the turbine itself can start to interact with its own wake in several instances, and with lower fidelity methods, you cannot analyze such phenomena. Then, since we resolve the wake explicitly, you can also start to try to model the interaction between 2 wind turbines that follow each other. So that's, of course, a step up compared to the BEM method. But it also gives us, or researchers within the consortium, the opportunity to optimize control designs that don't only focus on one single wind turbine, but also on packages of wind turbines to increase the overall power output for a pair or for even a wind farm. Very important to us also was that we distribute this tool in a public and free domain so that students can take it up and start to get running in the field of wind energy research, but also researchers can just take a free tool and apply it to whatever research they are working on. So the development that we had to do was basically taking the wind turbine simulation tool offshore. So we had to model the boundary conditions. Of course, that includes waves, that includes the soil interaction with the wind turbine, and also the kinematics from the waves themselves. So we implemented a quite straightforward linear airy wave theory then. Then we have to focus on the structural model as well, because now, since below the tower there are additional structures that need to be modeled. And as you can see here, to your left there's the soft wind or the spar-buoy type platform. To your right there's a jacket, fixed bottom offshore wind turbine. This structural model needs to be very flexible in the way it's set up, since you have to be able to modify or to build up very different kinds of offshore structures. That also includes mooring lines, of course. Here's an additional, or that reinforces the point, because one of the main topics I think that will still be discussed later on is that we haven't converged to a optimized floater yet, and there are several options out there. And well, to be able to land at a very good or the best solution, you need to be able to analyze each of them. So that tells you again how flexible the structural model needs to be. And of course, we need to model all the dynamics and all the forces that occur on a floating offshore wind. So above sea level, you have all the root bending moments, the aerodynamic forces, the gravitational and inertia forces, and so on. But then if you go below the surface, there's also the hydrostatics that you need to account for, the radiation damping, the diffraction problems, also the hydrodynamic forces that act on the softer cable elements of the mooring system. So for all those things, we started to implement several models. And to those of you who are into hydrodynamics a little bit, we have basically, we're matching the state of the art there, where we can model the substructure by splitting it up into a strip theory approach and then applying the Morrison forces to each of those elements. But also we have coupled cuBlade to several potential flow solvers, one of which you will hear about in a couple of minutes in more detail, that in a pre-processing step provide the excitation forces and the damping force coefficients from which we calculate the transfer functions and ultimately solve the forces in the time domain. And that includes also, as you can see here, the quadratic transfer functions that are quite important for nonlinear excitation. And since not every boundary element solver is able to solve those, you will hear about the integration of this into NEMO in a second. So when we did all of this, this is basically the result that we landed in, and you can see to your left there's a tetraspar, then there's a spar type, or spar-buoy type platform, a semi-submersible, or even a vertical axis wind turbine, also on a spar type platform. So if we play the video, that seems to work for once. That's nice. In a quite severe sea state. And then there's also the interaction that we can start to simulate, which is quite interesting, especially for the ones from control, and also cases like this one, but that's for another day probably. Some other examples of the flexibility of the code is some consulting projects that we have been working on, where there's a mixture of floating and fixed bottom offshore wind turbine with a dual rotor concept, or shared mooring concepts with semi-taut mooring lines. Everything basically is taken out as a screenshot from cuBlade. Since all the validation again doesn't mean a lot, all the code development doesn't mean a lot if it's not verified thoroughly. We have run comparisons against the soft wind experiments at École Centrale Nantes. We have run, or we have simulated the cases from the quite famous OC5 campaigns, and also carried out DLC load cases in over 750 sets of simulations to compare the statistical alignment between our development and the state-of-the-art codes like DeepLine Wind or NREL, NREL's Open Fast. All of this was published in quite a few technical reports, as you can see here. I think it's 7 in total. We've written a user manual and a theory guide that can be found in the cuBlade Reads Docs page. And there are also 2 scientific publications pending, and they're currently in the wind energy science discussion phase, and hopefully they will be published soon, before Christmas, hopefully. Then the code was launched in the middle of last year. We ran a public or a semi-public workshop with over 30 participants, and it was caught up quite well, and everybody got to know how to use these new features within a 2-day workshop. The website was launched during the same time from where you can access the documentation, but also you can download the code. And we have participated also in quite a few fairs and exhibitions and conferences. So lastly, I think we went to Glasgow, where we presented some of the results that I've shown you now. And my last slide is to show you the impact that Kubelet has until now, or has had until now, with over 27,000 downloads worldwide since 1.5 years, with basically almost each country in the world having used it by now. The top countries being the United States, United Kingdom, and Germany. So that shows you that all this development has had quite a lot of impact, both on academia and students, but also on research. And with that, that's my last slide. So I'll hand over the mic to my colleague Guillaume.
Okay, thank you, Robert. I don't know how it's working. But,
Sorry, just 1 second.
Yeah, should be.
Now it should be fine.
okay. Okay, so thanks a lot, Robert and Navid, and all the organizer of this final info day. So I will just continue what Robert was saying by making a small focus about NEMO on the development that has been achieved during the Floatech project. So just for the ones that do not know about NEMO, so when you solve wave structure interaction problem, like Robert has presented for a floating offshore wind turbine, you need to have a hydrodynamic database that describes how the waves will interact with the structure, and that's the main objective of the NEMO solver. So this NEMO solver is what we call a frequency domain BEM solver that solves without any forward speed this wave structure interaction problem. So this NEMO software has quite, let's say, long history in École Centrale Nantes in France. So it was developed in the late 70s. So you see it's an old topic. But at that time, actually, this was the only thing we can do from the numerical point of view to solve wave structure interactions, because it needs to be very efficient at that time. You can imagine that the computers were not as efficient than today. So we have a long history starting from Aquadin. After, in the 80s, it's transformed in Aqua Plus with some few modifications, and after quite a long time, nothing happened really, up to the 2010s, where quite a huge work has been done by my colleague Aurélien Babary in order to refactor this Aqua Plus solver into what is now known as NEMO. And after, one of the big job that has been done at that time is to release open source this linear wave structure interaction solver, that became the world's first open source solver to solve wave structure interactions. And that's why it has quite an impact at that time for such kind of tool being widely used in the community with something like 4,000 users or something. So this was the starting point of Floatech. So what we have done in Floatech is that we have released new developments which are still open source, keeping the same idea that what Robert has presented for Kubelet, to have an open source suite. And we have integrated some very interesting enhancements to the original NEMO solver that I will very briefly presenting. So in this NEMO, which is known as the NEMO 3.0, okay, third version. So the first interesting feature that we have worked on is from the pure numerical point of view to really enhance the numerical efficiency of the software. Not going into details, but it should allow us to have more refined grid, to take multiple platforms into account. So in order to have, let's say, more efficiency in the solution to address the problem in a more efficient way. So from a pure applicative point of view, that's always interesting to increase efficiency, even if those kind of software is pretty fast if you compare to time domain solvers. So after other interesting features that has been added to this NEMO solver, this is quite a well-known issue with potential flow solver using a boundary element method. This is irregular frequency. So in some conditions, you can have some kind of instabilities that appears from the pure numerical point of view, and you have some strategies to remove it that we have included in this new NEMO solver in order to remove at particular frequencies some unphysical behavior that has been corrected in this new version. And after, as it's not moving anymore. Yeah, okay. And probably the most important new feature that we have in this new release of NEMO, this is the inclusion of second order wave loads, which is known as QTF. So those second order wave loads are especially important when you design a floating structure for the design of mooring system, because this is at the origin of the low frequency motions that you have on those platforms, which are very important in terms of design. And actually, from the, let's say, numerical point of view, it's quite complicated to include this in the solver. So this is why it has not been done a lot in the literature. And this is what has been included in this new version. And we have validated the developments thanks to state-of-the-art commercial codes. So we took as a reference the Hydrostar code, which is developed by Bureau Veritas, which is a classification society that is well known for his expertise in terms of such kind of solvers. So what is the current state that we have? Here it's just a kind of comparison between the most well-known commercial codes that are solving wave structure interaction problems. WAMIT on Hydrostar on the left-hand side, on the new NEMO, which is the last column, that has most of the features of the commercial code. So still some few things that could be done if some people have some time and interest in doing few development in such kind of codes. But let's say that all the work that has been done recently allows us to have a numerical model which is almost at the state of the art of commercial code, but which is now released open source. And for sure, this is the first and only open source BM solver that is able to solve for full QTF computations. That is, to our mind, very interesting for the community. So as Robert has mentioned also, we have several publications on this work. So if you're interested, you can have a look at it. I thank you all, and probably we'll take some questions with Robert. I don't know how it is organized, but thanks a lot.
Thank you very much. So now I'll give the floor to Jan-Willem van Wingerden, please. He's a full professor at Delft University of Technology and working on wind turbines and wind farm control. He'll be talking about the control technologies, and that was a collaborative work. So even though he's from TU Delft, this work was also done by TU Berlin, ECN, Sea-Power. Thank you.
Yeah, thank you for the introduction. Let me see. I did nothing, eh?
Sorry, one second.
Yeah, I clicked.
All right, now it should be fine.
Okay, I want to go back. Yeah, so I have the honor to talk about the control technologies, and I would like to acknowledge indeed the shared work with TU Berlin, ECN, and also Sea-Power. So I'm going to talk about the control technologies already introduced by Navid, That's covered in work package 3 and work package 4. So in work package 3, we are talking about feed-forward, wave feed-forward control. So I'm going to talk about that. And I'm also going to talk about active wake mixing. So let's start with the first technology. So let's start with the first technology. It's wave feed-forward, and where we started and where we are now. So at the beginning of the project, we had LiDAR feed-forward. So most of you know LiDAR feed-forward, right? You measure the wind, and you use that preview information to reduce loads or increase the power quality. So at the beginning of the project, hey, can we do something similar if we measure waves? So if we measure waves, can we then also reduce the loads or increase the power quality? Right? So the first thing that you need is a certain sensor. I'm going to talk about a little bit later. But the spoiler alert is no. I mean, you cannot do the same thing as with wind feed-forward. Still, you can reduce the loads, you can improve the power quality, but you see that most of these things are dominated by wind, or you need really big pitch actions. Spoiler alert. So I will come back to this. So what is it? What is the concept? So we have a nice floating turbine with a nice fish there, thanks to Daniel. And then we have preview information. So we have preview information, so we use the technology from Next Ocean, also a project partner. And Next Ocean is providing us with a preview of the incoming wave forces. So then the question is, if you have these wave forces on the floater, can you use that information to increase the energy capture, higher energy quality? Or can you also use this to have a load reduction? So that are the two questions. So how does it work? I'm a control engineer. I love block diagrams. I love transfer functions. So this is basically a schematic. So what we did is we used Qblade. We just derived linear models out of that using system identification. So we excited the forces on the platform with a certain signal. We excited the blade pitch, so that's the signal at the left here, and then we try to learn all these type of dynamics which are in the system. So that are all these yellow blocks, we call them transfer functions. So if you have them, then for instance, you would like to control the rotor speed, or you want to control the platform motion, then you just take these transfer functions and you come up with your feed-forward law. So your control law. So you get the waves in, they are creating these forces on your platform. We use the technology from Next Ocean. If you can measure them, if we have information, then you just plug in your feed-forward control. So your feed-forward control, if you take this expression and you fill it in, then in this case, your rotor speed will stay constant or your power will stay constant. So that's the controller that's focused then on power quality. Now, we can do something similar if you would like to target platform motions, and you get a different type of control law. So that are the two types of control laws we tested. Now, then you get results, right? You get data-driven. I will be really quick here, but for the control experts, it's a Bode plot, and we just build a controller based on data. And we implement. So if we implement, we can use OpenFast. We used Qblade, and we also did experiments. So I would like to stress that the controllers are designed using Qblade. So we did the data-driven modeling using Qblade, and we do the implementation experimental. So the results that I'm going to show are the experimental results. So we also have really nice numerical results, but for now I'm going to present the experimental results. So thanks to ECN, thanks to Félicien, I have this really nice movie. So you saw we have waves. We have here a floating turbine where you can also capture the motion of the floater. And you see on top where we have some vans spinning, and these vans are mimicking the thrust force on the floating platform. There's also a system that can measure the waves, and again, we can then predict the forces, and then we can do feed-forward control. So these experiments took place earlier this year. It took some time and effort to get the controllers working, but at the end, they did. So now I have to make sure I go to the next one. So then typical results. So what you see here at the left is time domain. At the right, it's frequency domain for a certain condition, in this case, low turbulent conditions. And this is the baseline, so only feedback control. So this is power. This is what the actuator is doing, our blade pitch. And this is the platform motion. And here you see the spectrum. So if we now have a controller that will target the power quality, right? So that's one of the objectives. Then you can see in the time domain that, hey, if you look at the power, maybe it works a little bit better. If you look at the frequency domain, the red one is below the blue one, so it seems to work. But it doesn't affect the low frequencies because there we have wind, right? We cannot use wind because this is only using wave forces. Then you also see that, hey, this pitch requires quite some pitch action. So you have to turn your blades quite a bit. So then you see that your action is going up. And here you see the platform motion. There is an increase even a little bit of your platform motion. So what you can conclude here is that you can increase the quality of your power signals, but I mean it's really dominated by wind. Now then we can also do a focus on the platform motion, and that's really tricky. So if you now look at this figure here, this is the platform motion, so you can have some reductions. So there's a tiny reduction, right? But if you want to have more reductions, then you need huge blade pitch actions. So that is the downside, I would say, of this wave feed forward. So you can do stuff, but it's really limited what you can do, especially if you look at numbers. So if you look at numbers, so here's the power quality. So again, this is with respect to baseline. You have a better power quality. This is what you have to do with your pitch, and this is what the platform. So there's a small reduction. So again, this is the one for a power control. If we then do platform pitch, now then you see that you can have reductions, but you also see what you have to do with your blade pitch, right? So we can do it, right? We can increase the power quality, we can reduce loads, but you need big pitch actions, and it is robust. So I only showed the results for a particular case, but we have done different turbulence intensities, also wave spreading, different directions, etc., all during the experiments at ECN. So that's the first technology. So then let's move on to the second technology. And again, let's start where the first results at the beginning of the project, and let's go to the end. So this is where it started. So this is a wake of a normal turbine, right? And you see that you have a really long wake, and the idea is to look at the effect on the wind farm level. So the concept of wake mixing was there at the beginning of the project. So what you can do is called the pulse. So you excite the system with collective pitch control that you get wake mixing. And that's really nice because you see some mixing in the wake. And there's another technology which we call the helix. And the helix is doing the same thing, also wake mixing, but the power of this turbine is constant, while here you see huge fluctuations. What is the nice thing about wake mixing? That if you put a turbine in the wake, that second turbine will produce more energy. So that's what you see here. So if you go from baseline to pulse to helix, you see that you go from 6.1, 7.2 to 8.2, right? Uniform inflow, 5D spacing. 5D means 5 diameters of the rotor. Potential, right? So this was the beginning of the project, and then we thought, okay, what can we do? Yeah. So then the begin. So can we use the concept of wake mixing also if we put it on a floater? right? So what happens if we put this technology on the floater? And what type of frequency should we use? What type of amplitude should we use? So spoiler alert, does it work? Yes, it does. But you have to be careful with the frequencies that you use. You can do co-design, so that's something we did with C-Power. And you have to be careful with the type of floater that you're using. So also the platform dynamics matters. So that's the spoiler alert. So how does it work? Again, thanks to Daniel, this animation. So there is wind coming in, and if you're going to do the pulse, then you change the thrust force. So if you change the thrust force, the platform is starting to move. So you can imagine if you have the right dynamics there in the wake, that you get maybe additional wake mixing. That was the concept. So that is for the pulse. And if we do that for the helix, what you do with the helix, you make a yaw moment and you make a tilt moment. So you can imagine if you have the right design of your platform, I'm doing the helix, Daniel, so then you get additional yaw motion of your platform. So can then also have a little bit of wake steering if you have the helix on your turbine. So again, we use QBlade. We use QBlade a lot, especially also with multiple turbines. It was really useful. And we also did experiments. And again, today I'm only going to show the experimental results. We also have a lot of numerical results. So these results are relatively new. They are from a month or two ago. So what did we do? We put a scaled turbine in the wind tunnel in Delft. So you see it over here. And this small turbine has the capabilities of doing individual pitch control and collective pitch control. And we also put it on top of a motion platform to mimic floating motions. Now, in the picture here, the right, you see at the back, you see some kind of seeding system. So what we do is we put soap bubbles in the flow. Now, these soap bubbles we then capture with a couple of cameras, and then we look at all those soap bubbles, and then we can reconstruct the flow. That's what we have done. That's what Daniel has done. So then some cool movies, that's how I should call it. So here you should see the wind tunnel in Delft, and here you see underneath the plastic, there's the hexapod. We have to protect our hardware, right? We're working with soap bubbles. And then you see also the soap bubbles, and you see the light on top, right? A typical experiment is like 10 seconds or so. I think this is even nicer because this is still normal operation. At some point you will see that we will put the technology on, and you see it now. So you really see the helix movement in the wake, right? Of course, these are just movies and making movies of soap bubbles. You can do much more with it, right? So you can do analysis, you can look at flow fields, and you name it. So just to give you an idea what you can do, I mean, we have a huge amount of data, and we still have to do quite a lot of processing, but you can really reconstruct flow fields. Now, at the left, you see if you have the helix without a floater. At the right, you see the helix when you put it on top of a floater. You don't see the difference, right? But what I would like to highlight here is that we have these circles at different distances, and then we can just measure the mean velocity, and then we take it to the power 3 as a measure for power. And then we can really compare baseline versus helix, helix with a floater. So that's this picture. So what you see here is, again, the distance, so the distance behind the first turbine, and then you see the relative power gain. So if this is the baseline, of course, it's 0, because that's our reference. If we now only do the helix, so the platform is standing still, then we get these type of gains, right? So depending where you put your second turbine, at 3.5D, you are in the magnitude of between 15 and 20% gain. Now, then it goes up a little bit, up to 5D, and then it will probably settle. What happens now if we have the right dynamics of the floater? You can also have the wrong dynamics of the floater. That's a lot of research and a lot of deliverables. You can find the details there. But if you have the right dynamics of the floater, then the floater is really helping you. So what the floater then does, you get additional gains. Based on the movement of the floater, then you go from, again, if you go at 3.5D, from between 15 and 20, you go between 30 and 35%. So what you see here is the huge potential what you can have with wake mixing on the floater if you do the design right. Right floater, right frequency, and you name it. So to conclude, wave feed forward, yes, we can improve the power quality. Yes, we can reduce loads, but we need huge pitch actions, blade pitch actions. Wave mixing, yes, I think wave mixing really has a huge potential, up to 10%, also if you go to more turbulence, intensity, and Q-blade simulations, because of course the wind tunnel has nice uniform inflow. And we're ready for the next step, so we also will continue in float farm with wake mixing. So that's it from my side. Thank you for your attention.
Thank you very much. Yes, I'll take it. Yeah, thank you. Thank you. So the last presentation before the break is on the LCOE financial breakdown. I'll give the floor to Domenico Coiro. He's a full professor in aerospace field at University of Naples Federico II. He's also a non-profit research consortium, Sea-Power, supported by the University of Naples, and a partner of Floatech. And he has more than 30 years experience in renewable energy from wind and from ocean energy. Thank you.
Thank you. Thank you. And I will have the hardest part probably, because wherever we study and we do, then we arrive at cost money, at money. And so the final objective of this project was also to verify what is the saving in money, or in other words, how we can reduce the price of final energy produced by these components. So the objective of work package 5, which was the main objective of our work with Sea-Power, was that of estimating, to set up the procedure to correctly estimate the levelized cost of energy, which is a sort of cost of energy actualized today. And to do this, you need to basically to work to evaluate how much the turbine would cost with capex, so the cost of components of material, plus you need to add the cost of operational and maintenance of the turbines, and then the commissioning cost at the end. These are on the upper part, and then what you want to do, you want to minimize the number. It means that you want to increase as much as you can the annual energy production of the turbine, single turbine, or a farm of this floating turbine. And the duty was that to evaluate what would have been the impact of this technique that Jean-Willem just presented before, controlling technique, on the costs. Because obviously, if you set up some controlling technique and then they do not have an impact on the cost, probably is nice scientific job, but you need to prove that with those control technique, you are not increasing the cost of a final energy. Oops, sorry. Just to remind to all of us what we're talking about of turbines, in this case 10 megawatts, so which is not the largest turbines today, that we are setting up on a floating platform. These turbines are 178 meters, this one specifically in rotor in diameter, but the impressive number is the amount of, I don't know why the pointer is not working, right? But those go on the screen, sorry. But it's the amount of total weight of the turbines, of which most of this 24,000 tons of steel, 22,000 out of those 24 are related to the floating platform. So we are talking of massive systems, generally speaking, along with also, mooring lines, very long, 750 meters, 800 meters. And so the objective of reducing the cost of components and so the increasing of energy from another side are two important components in order to minimize the cost of energy produced by these turbines. So the procedure for the estimation of a cost is that to split the turbines in its main basic components, which are tower, blades, platform, and mooring. For each of these components, you need to set up a modular, in a modular system, a way of evaluating the cost. In other words, means if you increase the load somewhere, how this load, or reduce the load, how this load can affect the cost of that component. So you have to do some calculation, evaluation in order to see if thickness of steel is going to increase or reduce. And at the end, you make the costs of the components proportional to the, let's say, the material, the mass you have at the end of this single component. Then, after you have done that for a single turbine, then the same procedure, somehow you have to report for a farm. So when you have a farm, things changes because obviously you have a number of turbines altogether. Each turbine is producing differently from the turbine in front of it because it depends on the wake, as we'll see now. And then you have to set up also a procedure to evaluate what is the energy production of a whole farm made of a certain number of turbines. How you do this cost evaluation? In the cost evaluation, there are many components. First of all, the first part is the simplification of a structure, because it's very hard to have a very detailed analysis of the turbine. So you simplify the structure to set up a general cost model. Then you need historical cost data, historical data regarding the turbines. You have to assume discount rates, for example, inflation. You have to assume some inflation in order to foresee the performance of financial things before even within 20 years. So use some statistical models as well. You have to take in account the material price variation. As we know, in the last years, price of steel, for example, has increased significantly respect before the war, for example. And also labor costs are all components that get into the evaluation. In the same way, you have the modeling of those components, as we said before, and with all this information, you can set up cost modeling of the turbine. So the procedure from this point of view, when you have this modeling somehow verified, is relatively straightforward. So you take the components, you set up the model to represent the components, then you see which of these components are affected, for example, by the control, by each of the control we have seen before, and then you evaluate all this one, and then you see if the effect of cost of energy, how much is that effect, if that would increase the cost of the energy produced, for example, for the control, or if it will decrease the final cost of energy. Just to give you an example how to produce, how to evaluate the energy of a whole farm, as you can see in reality, the wake have this sort of, the wake of each turbine, is open. We have seen also the video of John William before. And so you have to assume a modeling this wake, the shape of this wake in a simple way in order to evaluate the whole energy the whole energy produced by the whole farm. So what we did is simulating, assuming a shape of these turbines set in one in front of the other, and we assume some shape of the wake such that with the simple model you can evaluate how the turbine following the second turbine, the third turbine, fourth turbine is affected by this wake and how the energy is reduced. And you have to do this in a combination taking in account the wind variation and also how the turbines are set in the farm. And this has been done using obviously a lot of run using Kubelet developed in the same project. So you have to take in account different combination, wind direction, wind speed. You have to take in account the meta-ocean condition where the turbine is set. So there are a lot of parameters to take in account to make this sort of evaluation. This is not a simple task due to different high number of possible combinations. At the end, as already John William anticipated, if we see here starting point of a baseline, which is 176 euro per megawatt hour, which is a sort of average today, very high prices, we can notice. And this is the reason why this is the price for 100 for each megawatt hour produced, which is high compared to the same fixed bottom offshore turbine, and it's high compared to the onshore turbine. The reason why Floatech is here is just to try to reduce the price of this floating wind turbine, which actually is still high, and we try to bring down. So this turbine here, this is the price of a single turbine, but when it goes in a farm, as you can see, the price goes first down depending on the number of turbines. As you rise with the turbine number up to 47, the price is going to let's say, increase, but it is still less than the price of a single turbine. Here you can see how the impact of feed-forward wave control that we have seen before is none on the LCOE. So here there are two curves, one with LCOE with control and one without. So there are no impact on that. But as Jan William said, the impact, major impact of this type of control is on the power oscillation, reducing power oscillation, which is a power quality, how you deliver the electricity to the grid. Less power oscillation means better power quality to the grid. So everybody's happy about this, but regarding the cost, there are no impact on the cost. Differently from that, the active wave mixing, as John Williams showed, shows a very significant reduction, also almost independently on how many turbines we are installing. Actually, in case of using this control, we can see that the rate of increasing the number of turbines is less respect to the case of not having that control. So we can see that with the control, we can keep the price much less respect to the case without the control. And so we can reach up to 6% of reduction of energy, cost of energy, which is an interesting number, at least for a farm of 50 turbines, 49 turbines. So probably if you go more, we are almost in a flat part, but we can still gain something for a larger farm respect to this one. So the conclusion, as we do, the good part of this project is that we have developed somehow a model for generally, let's say, represent the cost of the turbine, not only the cost of components of a turbine, but also the cost of energy for a single turbine and for a farm turbine. This can obviously and will be improved probably in the next project, but as for now is a good basis to, let's say, to be implemented probably in the future inside, let's say, the general procedure for designing the turbine. So you can include the cost evaluation directly in a design procedure such that the design will take directly in account the cost of a procedure, or also, for example, the control. At the end, we could come up with a 60% reduction of LCOE, which with wave mixing, as we said, wave mixing control technique, which I think is a good, I mean, at least now on the paper, is a good results. Okay, thank you very much.
Thank you, everyone. So we're running a bit short on schedule, but what we can do is 10 minutes break, and we'll come back at 11:55. Thank you very much.
Hallo? Hallo? Okay, now yeah, we can hear you.
everyone have a seat, no problem. So, for the next speaker, in the evolving landscape of offshore wind, it is time to delve into a crucial aspect, often overshadowed, the gender perspective. So let's welcome Marie-Laure Ducasse from the Floatech project, an R&D engineer in fluid mechanics currently working at SAIPEM. Thank you.
Okay, thank you, Ines. So yes, let's move away from technical aspect a little bit and talk about gender gap issue. So as many projects in technical field, we have an underrepresentation of women. And even if you are a poor observer, you have seen that up until now, only men have made some presentation. Ah, okay. Yes, sorry. So just maybe not everybody know, but in European project, we have a gender equality plan in place, and it's a criteria for all the projects from EU country or non-EU country. And for the Floatech project, sadly, we had a really bad gender equality index. So based on that, we decided to organize a webinar next September, who was called Women for Wind, and we wanted to encourage women to pursue career in wind energy sector. Okay, so during this webinar, we wanted to highlight all the initiative ongoing and to share our experience as women in wind energy sector. So here just a reminder of a few initiatives ongoing. We had Laura Alonso Garcia who talked for the MATES project. So it's a project on maritime side, but on shipbuilding and offshore renewable energy. And on this project, they try to emphasize the role of women and highlight the diverse career opportunity. We have also the chance to have Sarah Barber for Eastern Switzerland University of Applied Science, who talk about a new committee called Diversity, Equity, Inclusion, who was built in the European Academy of Wind Energy. So this new committee wants to address question about women gender, but also all minority. We also had a presentation of role model from our project. So with Magali Mourez from BVD Hall, myself, so more on the industrial side, and also Sandrine Aubrin, who was represented the academic side on our project. And we had also the chance to share the experience with Vasiliki Clonary for more an institution, Wind Europe. So on this webinar, our goal was also to have to give a picture of what we are talking now. What is the representation of women in the wind energy sector? So just to start with education and research side, if we take all the field, women outnumber men in the up until the master level. But if we focus on certain field, like the one which called STEAM, so the one we concern us on this project, so STEAM stands for Science and Engineering student, Science, Technical, Engineering and Maths. So on this field, we see that it's not anymore 50% of women, but it's dropped down to 32% of women at level 6 and 7, so it's master level. Level 8, it's at the PhD level, so we go up to 38%. And as in a lot of area, when we go to the top position, we call here grade A, so it's for professor level position, we go down to 70%. So now, away from academy, but in the industrial side, the employment of women in the wind energy sector. So as you can see, 32% of women work in the renewable workforce. But just if we go to only to the wind energy workforce, it just dropped down to 21%. And what is always interesting is to break down this number into a function. And as you can see in the administration function, so all the support staff, we call it, we have more women with 35% of women. But if we look at the STEAM, what we talked earlier, so STEAM, it's mainly engineer position, we drop down to 14%. And as previously, top position, senior management position, go down to 8%. So another point, it was a survey, online survey, proposed by Irena, and they'll also ask a question about perceptions. And it's always interesting because it tells a lot about us. So one of the questions was the perception of gender-related barrier in the wind sector between men and women. And as you can see, only a third of male acknowledge the existence of gender-related barrier compared to 2/3 of women. And again, about perception, so they ask about who is pay more in the wind energy sector. We don't have number, and it's just perception. But as you can see, men think that so 76% of men think that women and men are paid equally, and women are not agree on this point. So just to finish, a few feedback and conclusion. So we have seen that women represent only 21% of the wind energy workforce. And we can compare this number to the 32% of the all renewable sector and the 22% of traditional energy industry, like oil and gas. During this webinar, we also have seen that we have a lack of data for women in academia, working only really specifically on wind energy. And now what we need to achieve is closing the gender gap in the STEM, as I will remember, 14%. I think it's a number, a guess, which should be also around this number for academy sector. So we want to close the gender gap to achieve a society based on equal opportunity, of course. Gender gap, its team need to be addressed throughout the whole education, research, and innovation system. And last but not least point, it's on the institutional change. So we have unconscious bias, we have structural barrier, but we are also full of stereotype. And we need to break down all these stereotypes if we want to have a better balance in gender for the next generation. So thank you for your attention.
Sorry about that. Okay, thank you. Yeah. Thank you, Marie-Laure. Sorry about that. So now we'll welcome online Joe Saverin, who studied engineering and mathematics at the University of Queensland.
So I think everybody can hear me.
Yeah. Hi, Joe. I was just presenting you before. Yeah, thank you. So. Okay.
Sure. Okay, it's working. Yeah, good afternoon, everybody. Thanks a lot for the presentation. Extremely important topic. I'm going to be following up with sort of what's next for the Floatech project. So I'll present myself first. My name is Joe Salvin. I'm the postdoc researcher here at the team. I was work package leader for work package 1 in Floatech, and for our upcoming project, I'm going to be coordinator. So that's a nice segue into the next topic. By the way, I'm really sorry for everybody who's there in person. I would have loved to have been there today, but unfortunately I got corona a few days ago, so probably better if I present remotely. Okay, so as I mentioned before, the follow-up project is so obviously all of the presentations today have been showing the excellent work that has been done in the Floatech project. It's been an amazing collaboration, and we're very keen on working together with the same consortium. And the good news is that we will be doing that in our follow-up project, which Navid mentioned also before. So it's nice to publicly announce this for the first time. The name of the project is Floatfell. As Navid mentioned, you can tell from the title that the concept of the research really is moving from single turbine focused technology up to farm level technology. So that's what I'm going to be presenting in my presentation today. And I'll begin by sort of jumping in with sort of some of the overview of the project. So some of the key points. It was a Horizon Europe call at the beginning of the year, a research and innovation action, which we submitted the application to in March. This was approved in July 2023. It was a fantastic day because it meant essentially we would get to work together for another couple of years. Float Fund, as opposed to Floatech, is a 4-year project, a slightly larger budget, and the consortium has also grown. So whereas in Floatech we had 8 members, in Float Fund we're going to have 16, so it's a significant consortium. There's a lot of partners. But the good news is that it's a very nice mix of academia and industry. Okay, so I think we have a really healthy mix. We've added 3 academic partners, 3 really strong academic partners, and also we've added, I think, probably 5 industrial partners. So we're really jumping ahead. We're bringing in new technologies. And that's kind of what I'd like to go into more detail about now, is what's the contents of the Float Farm project. So I'll give you an overview first with our typical abstract. Here we see a couple of nice things together. There's quite a lot going on in the image, but if you want to get sort of a simple breakdown of what's happening, it's best to look at the 3 actions of the project. So with action 1, we're looking at technologies which are applicable to a single 4D isolation. So this is similar to what was happening in Floatech, but we're advancing the technologies there further. So I'll go into a little bit more detail in the following slides about what precisely I mean by that. In action 2 is where we're really looking at these farm level technologies, okay? So there's 2 work packages connected with that. One really nice and I think important feature of Float Farm is that there's going to be a lot more focus in this project on both environmental and sociological impacts. Okay, we also have a work package on economic impact, similar to what was presented previously by Professor Coiler. We also have a work package devoted entirely to environmental impacts, looking at questions of, for example, what's the impact of noise in the marine environment, what are some questions about circularity that we perhaps can answer, but I'll go into more detail about that soon. And finally, there's a cross-cutting action which kind of spans across all of these actions, and that's bundled into work package 7. So if you want to get a bit of a detail about the individual work packages and the communication between work packages, we prepared this diagram, and we see that we have essentially everything is really communicating through work package 7, which is where we're going to be doing multidisciplinary design analysis and optimization. And that's connected with work packages 1 and 2, turbine level technology 3 and 4, farm level technology and 5 and 6, which is really going to be providing inputs for our objective functions for optimization. Is how can we design these really with the focus of improving our COE on the one hand, or perhaps with the focus on reducing environmental impact. Okay, and of course, the standard termination communication and project management packages on. Okay, so I'll jump into the individual actions. This is a very high-level overview, by the way, because of course there's a lot of details. It's quite a substantial application, and we're really doing quite a lot of the projects. So I'll just present at a high level what we're doing here, and I encourage anybody who has questions, but if interested in the project, the players, or the research direction, feel free to get in touch with me at my email address here. Okay, so work package 1 is titled Advancements in Floating Turbine Design and Control. So it's being headed by Uni in Florence. So in this project, in this work package, we're going to be looking at a new reference wind turbine, which is configured for low wind speed regions. We're also going to be pursuing the control technology, which Jan presented earlier, feed for wave control. And we're also going to be looking at a new novel generator type, which has the potential to drastically reduce mass and rare earth material usage. In work package 2, as opposed to work package 1, which is in a very rough sense above the waterline technology, in work package 2, we're looking really at the marine environment, looking at innovative substructure solutions, mooring solutions, dynamic cabling. And another really exciting topic is that we're going to be, in one of the tasks of work package 2, constructing a scaled 15 megawatt turbine, so 1 to 10 scale, in the Murray Lab test site in the Port of Naples. So this is a really exciting idea and task, because we're going to be not only creating our own substructure and constructing it, but also we're going to be putting a turbine on top. We're going to have access to the control technology. So essentially what this means is that we're going to have a test platform in a representative marine environment, upon which we, for this project and in future projects, can actually test new technologies. So I think this is a real game changer in terms of having a platform with which we can more simply facilitate pushing up the TRL level. Okay, so that's just action 1. With action 2, as I mentioned earlier, we've got 2 work packages devoted to farm level technology. So here we're going to be extending the technology which Jan was describing before in terms of wave mixing, by looking at simulation of multiple farm technology, multiple turbine setups. Okay, so multi-turbine subthrusters, where we're going to be able to actually simulate and really look at how do we optimize control to improve energy yield and reduce our COE. We're also going to be looking at things like turbine synchronization. How can we take advantage of the flexibility of the mooring system in order to position turbines such that wake interaction is reduced. Okay. In work package 4, we're going to be making use of the hydrodynamic tools which we developed in Floatech to look at the question of farm marine connectivity. So by that I mean shared mooring, shared anchoring, and we're going to be doing also a really impressive experimental campaign, the Wave Tank at the coast of North, where we'll be looking for the first time at a fundamental investigation of shared mooring. Okay, so we have their test set up there. We're going to be providing a data set which is really useful for the development of these technologies in the future, for benchmarking, for example. And finally, action 3. So in terms of the technical, before I get to the MDAO, we have action 3, which is the environmental and sociological impact. So I went into a little bit detail about this before. What are we going to be looking at with these? We've got a few new partners in the project here, which are going to be looking at sociological impacts. We're also going to be looking at the technical side of the generation of marine noise through operation of the wind farm, and take a look at not only what is the marine noise generated, but then the next step in this research is to say, okay, what is the impact this is going to have on marine species? Okay, so we have a really strong partner, France Energy Marine, who have models for this sort of interaction. They're going to be looking at that and saying, okay, how can we maybe design our farm or our turbine units in such a way to reduce this marine noise so that the impacts on the marine fauna are reduced. And equivalently to Floatech, we have the economic impact work package. Again, it's going to be taken over by CPAL, which is great because we could see from Chris and Quora the great work that they've done, where we will advance economic models and LCOE models to try and provide quantitative data on what is the actual reduction in cost that we can achieve with these technologies. Now, I think a really important point to emphasize is that it's nice to simply introduce a technology in isolation, let's say, for example, a generator concept, but there's no real point in implementing this because you could just on its own and looking at simply the impact of this on its own within the whole of the turbine unit, because the reality is that for every new component, we redesign the system. This is why we really wanted to have a work package which focuses on this in Float Fund, particularly co-design of the turbine and control and platform, so that any of these introduced technologies can, one, we can really get realistic assessments of the impact of their inclusion in a holistic system, but two, bring the coupling in the other direction, such that, okay, we're introducing new technologies, how can we redesign the full system so that we optimize, for example, LCOE, or we optimize reduce environmental impact? Okay, so obviously there's quite a lot of topics which we're touching in Float Farm, but I for one can say I'm really extremely excited about it. So many interesting, cool things that we're going to be doing. And we're looking in so many new directions, and I think we have an enormous potential to really make a difference in wind energy technology and the wind energy sector. So if you would like to know more, keep an eye on the Floatech social media feeds. Also, please feel free to get in touch. There's my email there. And as long as you keep an eye on the social media, we'll keep you up to date with the events that are going to be happening in Float Farm. So I would love to have a question round right now, but I believe that there are some audio problems. So perhaps that's going to work in the next round, in case anybody has some questions that you'd like to publicly pose. Otherwise, yeah, looking forward to seeing you in any of the events that we might be having for Float Farm from the beginning of next year. Thank you.
Thank you very much, Joe, for this really insightful presentation. I'd like to thank you, all the speakers this morning, and congratulate all the Floatech partners for achieving this project. Do we have any questions? I know that from online we don't have any questions. People are a bit shy, but do we have questions from the audience? No questions. So that means that all the presentations were really understandable, and you got everything and you have nothing to ask. Okay, well, good. So the good news as well is that despite of the technical issues, we're right on time. So if we don't have any questions, you can go have lunch for an hour, and then we'll come back here. And we're really happy because the second part of the day is a panel discussion, which will be moderated by Lisette Ramirez from Wind Europe. So if we have no questions, let's meet in 1 hour for the panel discussion on the future of offshore wind. Thank you very much. Oh, yes. And please don't hesitate to go upstairs with your lunch, because there are a lot of more tables and seats for you to have a nice and comfortable lunch. Thank you. Good afternoon, everyone. So I'll kindly ask the speakers, today's speakers, to have a seat. I'll give the floor to Lisette Ramirez from Wind Europe, who has kindly accepted to moderate this panel discussion on the future of offshore wind. So, thank you. I'll give you the mic. You have a mic?
I have it here.
Yes, it's you. So, yeah, a warm welcome to Lisette Ramirez and all the speakers that will be introduced by Lisette in a few minutes. Thank you very much. You have a mic.
Yes. Okay, so we can, yeah, I'm a bit like, maybe I'm gonna move in this direction, don't worry, it's okay. So that we are all perfect. So welcome everyone back, thank you for that delicious lunch. And now we have a 1-hour panel debate followed by a 15-minute Q&A, so keep your questions till the end. And we have, now we're going to talk about the big picture. What is happening in floating wind? Where is the market today? What are the remaining challenges? And of course, how can research help all of these objectives that we have in Europe, but also globally? So without any further delay, let me introduce our panelists today. We have, in order, so starting on my right side, Guillermo Nuno, he is CEO of Blue Oasis. Then we have Athanasios Kolios, professor of DTU. We have with us also Alessandro Bianchini, also a professor from the University of Firenze. Navid Najeri, who is senior researcher from TU Berlin. And finally, Andreas Wallstad, who is a freelance journalist working a lot in offshore wind and energy in general. So here we are. It's a very diverse panel, so I'm looking forward to maybe get some different perspectives, not only focus on the academic part, but also on how do we see this fitting into the larger picture of the developers and so on. Let's start with, where are we today? Well, it's been quite some hectic years since the energy crisis kicked in. This was right after the COVID-19. And of course, the inflation has changed a lot all of the commodity prices that we have. In fact, for offshore wind, we've seen that the prices in the past 2 years have increased by up to 40%. This is impacting projects. We see also less and less projects getting financed. As a reminder, also 80% of the ocean has waters that are too deep, so more than 50 or 60 meters, to use the currently used bottom-fixed foundations, mainly monopiles. So taking these two conditions into consideration, what do you think is then the main competitive advantage, or what is really the value, extra value that floating is bringing into this picture? Is it going to solve any of these two, or anyone would like to start, or should I point fingers?
Point the fingers.
Okay, let's start with you, Athanasios. I see you took the, it was to give it away.
No, that's fine. I hope you can hear me okay. First of all, thank you very much for organizing this panel and the very interesting discussions this morning. I mean, definitely this Floatech has been a pinnacle project. So you mentioned about hectic times. So this is one way of looking at things. I would say that this times is also a test for the resilience of our industry. Because what we see is that prices are going up, there are supply chain issues, however, we're still increasing our targets for sustainable energy and energy coming from wind. And this is something that is indeed very important. So we are not only sustaining the targets, but we are increasing the targets. This means that we will need to harvest energy, a lot of energy, and maybe in different ways to what we are doing today. So no doubt, we need to focus in whatever it is we are focusing, but we also need to focus to floating wind, because this will unlock new markets, new locations, new countries, but also it will enable further innovation. So my quick message is that no doubt, floating wind, it is a time for floating wind. I mean, I started with research in floating wind 15 years ago, and there were many instances where we thought it's coming, it's not coming, but now it is definitely coming. So we're talking about more countries having legislation on the topic. It is becoming more real. But again, we need to see how we can enable this, and I guess that this is something that we'll be discussing later on.
Guillermo, do you have a different opinion as a developer?
No. I just have more aggressive opinion,
Okay.
as always. No, I mean, in Portugal, so as you maybe people know, I know some people here. I come from the Netherlands, so I saw the Northern Europe perspective, and now I'm in Portugal, the Southern Europe. In Portugal, it can only be floating. So our continental shelf is very deep, very fast. So there was an auction. The auction started also in Portugal, and 2 weeks ago there were, in the first declaration of interest, there were 50 companies interested on some part of the 15 gigawatts. So the interest is there from the industry and on floating. So these 50 companies, project developers, had to say that they were going to do floating. There's no other way, unless it's very expensive if you want to do more than 100 meters. So it's definitely floating. It's in Portugal or in Spain or in those areas, it's definitely floating. Portugal is a huge economic exclusive area, maybe together with Denmark because of Greenland. So there's a huge potential there for floating. The problem in Southern Europe compared with Northern Europe is the supply chain. So you can make everything here in Germany, but we cannot make everything there. We can only make coffee and a lot of nice food. But here you can make a lot of the things that we can make. So the supply chain and the European resilience and Europe as a whole making stuff to deploy somewhere else within Europe, it's a big problem. And in the debates we had in Portugal, everybody's talking about harbors, operation, ships for operation, and how to make the turbines, more even than the platforms, the turbines. Those are the critical points I want to point out.
Okay, let me pause a bit the discussion here because considering these two interventions, I want to address that I think there are two elements important here. So it was already said that floating, in fact, has been in the market, or let's say has been already proven for 15 years. So it's not really like a new something, okay? It's a technology, it's proven, but indeed it lacks the volume and the experience to also develop a supply chain. It has been mentioned as well. And it was also mentioned that it is a necessity. It is the only way to bring offshore wind to some regions. And also, despite, and this was a very interesting comment, despite the prices of commodities going up, most or all countries are increasing the targets. In fact, they have increased so much the targets that if we compare quickly where we are today, we have at the moment 210 megawatts of installed capacity in Europe for floating. And we are leading the world with this amount, which is less than 1% the total installed capacity in Europe, okay? And by 2030, if we take what governments are pledging, they want to do over 10 gigawatts. That's a massive scale up, or a massive step, if you ask me. So taking a bit this into consideration, I would like to ask then our other panelists, what are the main challenges then that the technology is facing in order to move? If we know already, if we are agreeing that it's needed, the commitments are there, then what are the challenges? Why is this not happening?
So my experience in Italy is pretty similar to that of Portugal. So floating wind is also important because it's changing the way our governments are, let's say, approaching wind energy. You know, in Italy, for example, the beauty of the landscape is a national asset. And so for us, refusals for onshore wind are like 70%. So instead, the idea of putting wind turbines in the sea is partially changing this. And we are seeing an increasing attention of our politicians and governments to this technology. There's going to be a national event on this in a few days from now. Regarding the challenges, so you know, I work mostly on the, let's say, technical side of the problem. So honestly speaking, from the technical side, I'm not that worried. So we had a lot of experience into onshore wind, and I think we can face the challenges. It will take some time, some effort, but we will find technical solution to make these turbines work very well. One of the challenges I can tell you, because I see in my countries, is what was mentioning before. So ensuring the supply chain, and especially the way of installing these turbines, is not trivial, because most of the countries where you have a lot of potential, like Portugal, Spain, or Italy, whatever, we have a lot of ports because we come from a maritime tradition which dates back to thousands of years ago. But the problem is that our ports are not that big in general. So for example, in Italy, there is a lot of discussion into, let's say, changing the mounting scheme of these machines to make it in diffused ports. So the idea could be that in the future I can have a port for, I don't know, creating the floater that then is then delivered to another port when we install the turbine. So this kind of stuff are really complicated, because in floating wind you need to combine space and infrastructure to mount the thing, and also the vicinity to the installation site, because of course you can tow these machines, but not for miles and miles. So to me, it's more a logistic problem to the moment, not a technical one, honestly speaking. So all these projects that we are seeing, the results of EU project, are showing massive improvements into the technology. So.
Okay, Navid, do you have a agreeing opinion, or something different is the challenge?
Yeah, well, I see some technological challenges, because it's as this Floatech project was motivated, we are seeing different, more complex interactions on the floating structure as compared to a fixed bottom. And we have a wide range of solutions or ideas how floating structures can be designed, how they can be fixed or not fixed to the bottom with catenaries or mooring lines or tension leg systems. So there's a vast variation of solutions, and that makes things much more complicated to make it a product which is cost efficient. And I think the cost efficiency, that's a huge challenge. And you see there are only a few major OEMs who attack this challenge of producing offshore floating wind turbines. And some are facing a lot of investment costs. And that's why we try, and I'm very thankful that we get this funding to have this project and to be able to help on finding ways to make the design and the decision on future solutions easier. And yeah, I think, so there are a lot of challenges in the technology part, and it's of course also for the industry a cost problem.
Andreas?
Thank you very much. I would say, yeah, the regulatory framework is a challenge. I would like to give an example from the UK. A recent offshore wind auction in the UK failed to attract one single bid for offshore wind. That's both floating and fixed bottom. The government responded. They increased the strike price, and the contracts were different. And I'd like to stop there at a little bit because the new strike price for fixed bottom in the next auction will be 73 British pounds per megawatt hour. For floating wind, it will be 176 pounds per megawatt hour. And I think that tells a story. You know, there's still a price gap between floating and fixed bottom. But one thing is the strike price. In the autumn statement, the government made some further adjustment to the regulatory framework. Offshore wind, like renewables and nuclear power producers, like in many other European countries, they are exposed to what some people call a clawback tax. So they basically excess profits has to go back to the state. In the UK, the threshold there is set at £75 per megawatt hour. So if generators get more than that, they have to return the money. And that system is called the electricity generation levy. That system will be in place until 2028. But in the autumn statement, it was announced that the government will legislate to exempt offshore wind from this levy, and as well as solar power as well. So, yeah, a well-designed regulatory framework. Most investors I speak to, they want clarity and predictability. Floating offshore wind is no exception there, I don't think.
Of course, you touched upon, both of you touched upon many interesting parts, so we have to maybe go one by one. Let's first dive a bit further on auction, perhaps, because it was mentioned as one of the key issues, and not necessarily the auction itself, but the regulatory framework. So in our view, it is indeed, I mean, many countries want to do offshore or floating wind. I mean, we have Portugal, Spain, France, Greece, the UK, they all have targets for floating, and they all have a plan already, even auctions that should be happening. But we do see also a lot of delays or things that are happening, and most of them, if we think particularly of the Mediterranean countries, is the lack of a regulatory framework, because it's the first time they are doing offshore wind. And this means they kind of have to set something starting from scratch, relatively, because we already have very good lessons, like from the UK and other countries, but it's taking so long to define these rules. So, I mean, what is really happening, and perhaps I ask here some insights from Alessandro and Guillermo, like what is really dragging the government in launching all of these auctions?
I have a political correct answer and the not political correct answer. I mean, the political incorrect answer is that, is there something new on that? And lack of regulation? I mean, that happens everywhere in Portugal. It's not only in offshore wind. But the political correct answer is that I think Portugal is seeing what happened in UK and in other countries. So what happened in UK is going to have a tremendous impact in the auctions, at least in Portugal, I know. If the UK auction was very successful, those prices, the Portuguese were going to do exactly the same. So I think that everybody's waiting to see the first auctions, to see the rules in order to take the steps. And from Portugal, we are always complaining, but we are always the good kid in the school trying to see what the Northern Europe is doing and trying to do the same. So I think that Portugal is waiting a lot to see what the UK is doing. That's one thing. The other thing, and I think that's important, it's the politics, the political situation. Now the government fell in Portugal, and with the new elections in March, nothing will happen until then. And I think that is in any country. I mean, if the government, I mean, this is more than a technical thing, it's also a political statement for any government. So I think the stability of the country also has an impact on these big endeavors.
But would you think that the elections or the change in March for the government could impact or change the road map that it's going to be these auctions, etc.?
Climate change, it's
staying in the agenda.
It's staying in agenda in almost in all parties.
Okay.
From the most left wing to the most right wing. Even the right wing party in Portugal is also raising as climate change somewhere a little bit lower, but it's there. And in a society, they teach that at school. My kids at school learn about climate change. I never heard about climate change, of course not. So it's really in the society. There is no way back.
Okay.
Yeah.
Great. Athanasius?
Well, first of all, it's great to be in Europe, because what you say, that all parties are pro climate change, it's a given thing.
Not pro climate change, pro against climate change.
Pro against climate, true. There are other places at the other side of the Atlantic where they are waiting for elections and things are not that secure.
Okay.
But again, building up on the previous comment, I would say that maybe trying to copy a successful or an unsuccessful auction may not be the best way forward. Because again, coming from Greece, and as Alessandro said, the landscape is a national capital. I think that countries need to have realistic regulations and realistic auctions. Of course, it's important to get learnings, but there is not one size fits all in this type of activities. So I think that there is a very thin line of trying to be prescriptive enough, pleasing all of the stakeholders, of course, but also we need to see at the bigger picture. And another comment that I would like to make is that we're talking a lot about costs and about prices. And of course, this is very important. I mean, this is how we make the technology more competitive. But will the auctions only rely on cost in the coming years? Or will we have additional criteria? Because, again, pushing developers to cut down on costs is one thing. Of course, we can do this. But we may end up awarding areas and then not executing the project, which is something that we have seen with fixed bottom wind farms, for example. I mean, I will not mention names, but we have seen it with at least 2 major manufacturers. And this is actually what the OEMs say. They say, please stop asking us to cut down on cost and think about the problem in a more holistic way.
Alessandro?
One point that I can add from Italy, as said, the awareness about this technology is increasing a lot. There are a lot of discussion. For us, it's completely new. So we did not have offshore wind up to a few months ago. You probably know that the first offshore wind farm is in Italy, but it's a very close to shore offshore, but it's offshore. What the government has announced is that they are trying to, let's say, to define permitted areas. So they are trying to define within our maritime space permitted area. And this is something that, of course, from one point of view is positive because testifies the increasing attention to that. But I've been participating to a couple of discussions, and experts tend to be against this approach and propose the opposite. So the opposite could be only tell me which are the denied areas, and the rest I can choose. Because one problem that project developers are experiencing is that they are, let's say, defining permitted areas based on a lot of constraints, and it's perfectly fine, as Athanasius said. But then it could be the case that this area is compliant with all the constraints for maritime transportation, landscape impact, and blah, blah, blah. But then probably the seabed in that area in the Mediterranean is not suitable to make moorings. And so you have created a permitted area, but it's not really permitted, so it's unfeasible. And so the idea, the proposal is to have a definition of the denied areas, combining constraints and, let's say, insights from the developers, because we know that some areas are not suitable to the seabed, to the currents, or whatever. So still a lot to do to have a solid regulation onto that. But at least we are seeing a positive trend after years of stall. So.
Indeed. Before I move on to another topic, and it's just to kind of close up on the auctions, because we hear a lot of insights. I very much agree that sometimes trying to just copy a model from another country might not be the answer. And we also know that northern countries and southern countries have things that predominantly work different. So, for instance, in installing a one-stop shop that we advocate heavily on, you probably know better than me whether it's an efficient way to work in your country or not. So sometimes not all of the things need to be just replicated. However, and this is analyzing trends from all across Europe, right? And what has mainly driven the cost down for offshore wind bottom fixed was the basically auctioning of capacity, large amounts of capacity, let's say 5 megawatt at least, and larger. Now there are sites of almost 1 gigawatt being awarded. So for us, the key things, if we say don't reinvent the wheel and take the elements that have worked, are to have technology-specific auction. That would mean that it's only for floating in this case. We say they must be, if possible, centrally developed. This means the government allocates the sites, although that might be something you disagree. The use of a revenue stabilization mechanism, and in fact, the use of contracts for difference, two-sided contracts for difference, like the UK, with the right ceiling, is the best way forward to drive the cost down. And of course, a robust pre-qualification process, which I would be eager to know whether these 50 applicants for Portugal are going to be able to all submit.
I want to add something about the technical stuff that people forget. I mean, there was a big discussion in the news in Portugal about people that are so-called experts saying that floating wind, it's a new technology, you should not go there, we should go to nuclear energy, these kind of discussions. And people forget, I mean, I've worked at Maren in the Netherlands before. The oil and gas do floating big platforms already from the 80s. So it's not a new technology. But the problem is that the floating offshore oil and gas are very profitable. So they can, they have even dynamic positioning. It's like, propellers putting the platform in place because they have a lot of money. The oil makes a lot of money. So the oil and gas industry has the floating technology already from the 80s. We should not reinvent the wheel also. What we have to do is decrease the prices. And another thing is, I think somebody touched standardization. There are a lot of platforms. There are a lot of different designs. And while we don't get to 3 or 4 that are standard, the prices cannot go down. I think it's with everything when we are making stuff, the standardization is what's the... And I think standardization is something we still didn't arrive. Like we see so many different platforms. Maybe on the blades, we are more or less standard, in the blades. There's a lot of different, there's like 2 or 3 different, but on the hydrodynamics, there's no standardization whatsoever. So, and that's, and I think these 2 technical things I want to say. In terms of Portugal, from these 50, there are like maybe 10 that are reliable, well-known companies. All the other ones I saw people that maybe made a company in the day before to, put the pin.
Okay.
So I think, but it was for the government, it was good to say to the public opinion, look, it's wanted. Everybody wants it. But I don't think it will be 50 in the next round, maybe it will be half of it.
Okay, but so from the few elements I listed, do you think there is something missing? Or that would be a good approach for the...
I think in Portugal we are very afraid of the environmental impact.
Okay.
So that's something that's... tourism is very important and people are very aware of we are a beach country, so environmental impact is really very important. So fishermen, environmental impact will be as important as the price. Because otherwise, everybody will complain, and if the public opinion complain, the project is not going ahead in Portugal, Latins can shout very loud. So if they shout, it's not going. So for instance, already in the news came the fishermen from Viana do Castelo, so it's where the wind float Atlantic is. They are shouting that they are not going to allow any offshore wind more project there if they don't prove that the fishing is not affected or if they don't pay them. You know, so they're already starting to raise the voices. So environmental impact is a huge, it's a tremendous topic, at least in Portugal.
Sorry, if I could add something on this. I'm not sure if this is environmental impact or perceived environmental impact. Because here, I think it's lack of communication, it is a lack of education of people. Because, I mean, again, coming from Greece, I think it's the same in Italy and the same in Portugal, people really feel that everybody dislikes offshore wind turbines. They will see it and they will not come to our countries. Actually, I do not think that this is the case. But the same goes with fishing. I mean, there are cases where actually fishing has benefited from offshore installations. I mean, we have artificial reefs and so on and so forth. So here we are talking about perceived impact, not real impact, which is, again, something that needs to be tackled differently. Yeah. Because it's not just an assessment that will relax people's concerns. We need to have campaigns, active stakeholder engagement and education campaigns. With respect to standardization, I think definitely this is a massive issue. If we compare wind energy 40 years back in the early 80s, where we were competing, so we're having horizontal axe wind turbines and vertical axe wind turbines. We had 2-bladed, we have 5-bladed, and all of a sudden we say that, okay, the wind turbine is a propeller on a stick. And everybody started developing this, and there was so much synergistic effect that the wind turbine became what it is today. And also, if we compare offshore wind with other marine renewables, we have offshore wind installed at large capacities, and we do not have wave energy converters. And again, 40, 50 years back, they were equally developed. And the reason is that, similarly to floating foundations, probably we have more than 70 concepts of tidal and wave that are developed in parallel. Again, no synergistic effects. So let's take this example on how we qualify the propeller on a stick and see how we can combine it with a floater.
Okay, before I ask, I had asked Alessandro for his opinion, but I want now to bring together quickly Navid and Alessandro on a question still related to the standardization, which seems to be a very strong topic and a massive issue. So we have, let's say, in the market, more than 100 different designs. And I believe when the first fixed wind farms had to be, let's say, selected on what are we going to do, there were maybe 5 different or 7 options of bottom fixed foundation. Now, of course, there is also the angle of how much can you innovate current design to make it even better, but does that mean it has to be a completely new design, or can we actually learn from everything we've done? Because if we see just as not necessarily the specific designs, but in big terms, we have 4 categories. So we have barge has been tested, semi-sub for a long time, spar as well, and actually the first TLP is now operational in France. So my question to the two of you is, in your view, because I also mentioned this because I believe, Navid, you had the chance to now recently being exposed to other cultures and see how they are tackling all of the standardization and mass production. But what do we take on this? Like, how do we approach or how do we achieve the balance of still optimizing the systems that we have while looking towards this standardization or consolidation of concepts?
Yeah, I think we have to do both at the same time. We have to start building things which are not leading edge technology, but just to make something cheap and possible, and get something in the water operating, like, for example, high wind in Scotland, this park. So we need some projects which really stop developing more and more advanced technology. We just need to have something which works now. And at the same time, we have to continue to find the best long-term solution to get something which maybe makes sense. For example, if you look at photovoltaic, that's maybe a challenging statement, but that has been so standardized, and China can produce them so cheaply, so that the whole of the world has equipped, I think, by 200 gigawatts solar panels in the world in 1 year, which is crazy. That's because it's so cheap now and can be produced so cheap. So we have to find a cheap solution now without continuing for optimization and take all the disadvantages just into account. But at the same time, continue with research for future generations of wind turbines. So that's floating wind turbines. That's the challenge we have to tackle.
Alessandro?
So from my point of view, we are like close to a flex in the learning curve. So we have developed, hopefully, it should be, in the sense that now we are surpassed 100 concepts. So in the end of the day, we need to stop and we need to come back to less design. I agree with what Guillermo said. Probably the future would be not one solution, how we did for turbines, but maybe 3-4 concepts. Especially because each concept may have specific advantages. So we know that there are some concepts which are more transparent to waves, some others are less, and they have different manufacturability and costs. So probably there's going to be in the future, so my idea at least, that we will have 3-4 technologies, and depending on the applications, because maybe you need some specific technology in a country because you don't have space in the ports to install the other one, or like the supply chain in that country is more suitable to produce one concept, or the metocean conditions are more suitable to one concept. So this is my vision, at least. And of course, this development that Navid was mentioning would probably, let's say, go hand in hand the hydrodynamic efficiency of the system with the manufacturability and cost. Because of course we can produce a concept which is technically super with perfect hydrodynamics, but then it's so difficult to produce or to install, as so many components, and in the end of the day it cannot be the solution. So my vision is that we will probably concentrate, and as far as I see, we are already doing something like that. So I can see 3-4 concepts which are now starting to be developed more than others.
Okay. Well, I also look forward to seeing that it's only 3 or 4 concepts out of 100.
Maybe not, but let's say it's my hope at least.
Yeah, we need that. Let's say that. Andreas, let me ask you, since you have been following the offshore sector for so long, and you also mentioned before when you gave the example of the UK raising the next round ceilings. And you mentioned as well that developers and the whole sector is asking for stability and visibility. So do you think all of this discussion about, okay, so many floaters, which should be the foundation, etc., is it kind of giving a perception that we are still kind of in diapers technology because they cannot even agree on themselves? Or in your view, how is the story of floating wind comparing to the, let's say, all of the risk that was taken when we had to just go for offshore wind in the first place?
Thank you. Well, I'm certainly listening and learning here. I wrote my first article about offshore wind, I think, back in 2008, about fixed bottom offshore wind. I could not get hold of one person who was optimistic about offshore wind. So the article in the end was very pessimistic about something that may or may not happen in 2040. I think if we stop and look back, fixed bottom, yes, there are problems now, as we all know, but it has come a long way, and perhaps a bit further than some people had thought, at least back then. I hate to go on about the regulatory side of things, but if I can give an example from Norway, when I Googled floating offshore wind a few days ago, I was a little bit disappointed to see that only 210 megawatts is installed. I must admit, I thought things had come a little bit further. And I think half of that is the high wind Tampen. project.
You're right.
There's another project, much bigger in Norway. It's called Utsira Nord. It's for 1.5 gigawatts, perhaps more. You had the oil and gas Equinor on board, shipping companies. The auction is delayed. The planning, it turns out that the planners hadn't taken into account EU state aid rules sufficiently. To go back to your question, I mean, if we compare it with solar power, look how, I mean, all of a sudden solar power was just there. Standardization, yes. Interest among the public, yes. I'm sure it will happen to floating wind as well once the regulatory framework is set.
Well, luckily, we hope that the floating sector is not taken from Europe like the solar sector. So this is something that the Net Zero Industry Act is looking at. I will not go there yet because I wanted to first quickly come back to the topic of, I agree with you, Andreas, it is a bit disappointing to say that we are leading, and we are leading with 210 megawatts. It feels, yeah.
So can I add one very short comment to this?
Yes, please.
I think what you mentioned is extremely important about retaining this technology in Europe. And actually, I think that the world has changed over the last, I don't know, 6, 7, 8 years, and globalization has changed. So now it is not that easy to get an idea, take it to China, reduce the cost, and bring it back for many reasons. And what we see is also a trend that will potentially reduce the dependence of European manufacturers from countries outside Europe. And this is something that we have seen with power electronics, we have seen it with applications and components that rely on, let's say, this type of imported materials. So, yes, I think that this may prevent floating from, let's say, leaving Europe. And the other element is that here we are talking about very big structures that still we are manufacturing them as ships. So every floating foundation is like developing a ship structure. So we have not really tackled the element of serialization of production. Yeah. So we are, I think, one step behind. And it's very nice that everybody says that soon we will see between, let's say, 3 and 5 concepts becoming the prevailing ones. Actually, this is exactly what we were saying 15 years ago. Okay. And to be honest, 15 years ago, we had a feeling on which are these concepts. Today, I think the same concepts are the ones that are prevailing, but we need to think synergistically.
Of course. So it will be mainly when we have, for example, Utsira Nord or a very large project selecting a foundation that this will become more consolidated, right? But you, and thank you, Atanas, because you made a perfect connection to the question I wanted to bring now to the floor. I mean, foundation actually, so because the cost of a project, even though wind energy has some of the similar components, starting by the turbine, but the cost breakdown, if you see an onshore wind farm, a fixed wind farm, and a floating wind farm, it is actually different. And for floating, that means that at the moment, and this is of course due to the lack of standardization and mass production, but at the moment, foundation represents about 23% of the cost of a project. And then if we add up on top of this the moorings and the floating specific elements, it comes to at least 1/3 of all of the project cost. Now, we don't have at the moment this supply chain, which is also has been mentioned before. So the question is, how can Europe develop and maintain the strong supply chain for these elements that are 1/3 of the cost of a project?
So one of the things in a supply chain, and I've seen, and it's something related with technological developments, is that, for instance, everybody can do concrete. Everybody can do walls, you know. Metallomechanics, so big structures like ships. There are very few countries in Europe that still do ships, you know. So one of the trends that we have seen, also to make the prices low, to make the productions locally, is to go to new materials. And one of them is concrete. So for the floater, we're speaking about the floater. Okay. So I've seen things that hydrodynamic, we should check what's the behavior, but for instance, for noise, it's even better because it absorbs the noise of the structure instead of the metallic, so it's much less noise. You can use salty water to make green concrete, as they're calling. So we should look also onto the aspects of, I think, related with what you are saying, not building a ship, because you don't make a ship of concrete, but of using different materials. And that you will see, a trend for doing things locally. I will not say 3D printing platform, but doing locally, because it will decrease also the cost, decrease the carbon footprint. So we should look into the new materials. And on the floater, I think that getting out of the metallic, metallomechanic production, it's a must.
Okay, Athanasius, Navid, or Alessandro, I will be eager to hear if you agree on that concrete is the way to go for floating.
Well,
one way.
It is one way, because I think what Guillermo said, that you have concrete in so many countries in the world, it's important. But the comment I will make, and again, we're in a university, and today we're celebrating a very big research project, is that maybe we need to change our thinking a bit. And here we are following a bottom-up approach. So we have a unit, and we are thinking, how can we produce 100 or 1,000 units? But actually the situation at the moment is that even if we consider onshore wind, fixed bottom offshore wind, and floating, if we continue to do what we are doing today, it's not enough. It is not enough to meet our targets. So maybe the discussion should be reversed. Where do we need to go? How many turbines we need? And how can we make it happen? And if I could use a parallel from a different industry, let's talk a bit about electric vehicles. So Toyota, they had Prius. For many years, okay, there was this interesting-looking car, but it was just that. And how did we have a shift? There was a crazy American who did Tesla. And the guy was not doing incremental steps, he did something very disruptively. What exactly do I need? I need the car that looks like this. I will not produce a new model every 3 years. And what do I need to do in order to make it? I need to go full industrialization. I need to have a gigafactory, a factory that could produce everything and rely much less in external vendors. And maybe this is where wind should go at the moment. So instead of thinking bottom up, let's think top down. What do we need to achieve in the next 20 years?
You can ask Elon Musk if he wants to.
I don't speak to Elon Musk.
Okay, Alessandro, I think you had a comment?
I agree with Athanasius' vision. It's complicated because, of course, the competing interests will arise in the sense that, for example, so me and Athanasius come from two of those countries we still produce ships and a lot of tradition of iron industry. So for these countries, producing a lot of floaters could be also a chance to reconvert our industry. So from the one end, this is very positive. So as like reconverting sectors which are like going down for years and years. On the other hand, I agree that we should think synergically as a country for one time instead of being a group of countries. We should think about like Europe and to select the best actions to promote the technology as exactly. So we need to let's say, combine the different requirements, but I agree that we should really focus on our target because we are running probably too slow to meet it for the moment.
That is true, but I think it's also, it's not that, let's say, Vestas or Siemens, GE are not willing to make a gigafactory of turbines. I think it's more like there is not that amount of demand at the moment for them to make that gigafactory. So it is a problem of like an egg and chicken that you don't have the auctions awarded and the developers asking for these turbines yet.
But there was also not a lot of demand for electric cars when Elon Musk did that stuff. So you have to have vision, I think. And so what he's saying is a good idea, Airbus, but the Airbus was an example of against Boeing. So we had to have an American company in order to do Airbus. So we didn't start with Airbus. So maybe it's with China, I don't know. But I think what he said, an Airbus for a floating wind, that's something I never thought about. So some parts are made in Germany, some parts are made in Spain, others in the UK, right? That's what happens in aerospace world.
Correct.
But not in the naval world. It doesn't happen very often, to be honest.
Correct, but even if we have a globalized, which we have a globalized supply chain, and this is what I have mentioned before. At the moment, now the Net Zero Industry Act, we saw the presentation before, so there are different provisions. The one that was put forward in March says that Europe must have 40% of the, or must be able to produce 40% of the needs that have to be installed with Europe, yes, with European technology. And now there are the negotiations happening at the moment, and now it has been said differently, whether it is 50% of the value of the components. If I just look at floating, if this will be passed right now, I already mentioned that foundation is almost a third, and if we don't have the place to make the foundations and we rig them, we are close to already not meeting that threshold. So that's why I pose the question. It's not that I don't agree that we need a globalized supply chain, but it has to be critical on selecting the elements that have to be brought together. I would like to start closing up. I'm mindful of time, and we also we're going to take some questions from the audience. They all still look like they are staying with us, so thank you for that. So now, considering the diverse of our panelists and going back a bit to the challenges, but also how can further research help on these subjects, and also where is really that we need new research, because we can continue. I mean, I'm extremely glad to see that Floatech is going to have a continuation, also with a broader scope on seeing the environmental and other factors that perhaps have not been taken into account yet. But so basically my question is, so the ETIP Wind, which is the technology and innovation platform representing the wind energy sector, is going to, it's about to publish its strategic research and innovation agenda. This, what it means is that we have listed, after talking to many experts, CTOs of the companies, what are the things that should be funded in the next Horizon Europe, in short. And for floating, we found the following as the key 4. Grid connections, industrialization of floating structure, which includes innovative methods for the construction and installation. So addressing major component replacement through digitalization, perhaps, and also the optimizing of the upfront designs of the substructure and the mooring system. Do you agree? Do you think something's missing? Or how are these elements coming together? Do we need other additional research, in your view? Navid, maybe you can start now.
Yeah. Well, I think these are very interesting and important topics which are addressed. From them, our project is addressing the last one, the design optimization, and that's addressed by Floatech and also Float Farm. We are also considering material reduction. That's an important issue, and I think it's also included in those points, maybe hidden, not at the first glance, but we are not looking at grid connection, but of course that's a major issue. We know that in Germany it's a big problem to get the energy from the North Sea to the south of Germany. We planned like 15 years ago, and it's still not established because of a lot of resistance from the society. Nobody wants to have cables on the garden coming from North Sea to South Germany. And so I think, yeah, and of course we have some other topics like control technology, as we have discussed already, which are somewhat included in those topics, probably again because they also help to keep the fatigue loads down and to extend the lifetime, and at the same time reducing the investment of material. So so I see that depending on how you interpret these titles, we are already addressing these topics, and they are very important topics also. Maybe one remark to your question from before regarding the supply chain. I think it's very challenging for Europe to provide all this material, and I really don't know if our European industry is strong enough to really provide 40% of all the, if we want to have 30 or 40 gigawatts of increment of wind energy, we have only 16 now last year, and we are already not able to, we have already problems producing electric cars. So I don't know, it's maybe a very ambitious goal to get that 40% locally in Europe, but that's now the other question.
Jan, please.
I think in the topics that you said, I want to emphasize the other ones that Navid needed. That is the digitalization, and I think the digitalization is more for decreasing also the operation costs. So digital twinning, it's a very hot topic. We also work in artificial intelligence and digital twinning for other things. So the way of doing operations and maintenance, like do not go so very often with ships or with divers or to go up into the towers. There's companies doing drone inspections using artificial intelligence, or doing with unmanned vehicles going to the offshore platforms, or you're doing digital twinning, so you can do prevention and prediction of what's going to happen with the turbine if the weather is changing in 4 or 5 days ahead. So this digitalization is important to decrease not the capex costs, of course it will increase, but the opex costs. So to decrease the operation, that's a hot topic. I see in agendas sort of a lot of not only offshore wind, but we know digitalization is everywhere, but digital twinning, it's a very hot keywords also.
Athanasios?
I'm a bit conflicted because I also sit on deep wind, so I have reviewed these bullet points and I find them perfect. With respect to digitalization, I think it's the scope is a bit broader, and it doesn't only have to do with OPEX, it also has to do with regularizing production, so linking it to the grid. But a contextual thing that I would like to mention is that, of course, we are asking for a fair amount of money for research, but we need to make sure that we get this money. Because what we have seen is that calls focusing on wind energy are not increasing. I mean, for Horizon Europe, they are decreasing. And the competition is increasing because now we have so many universities, so many researchers across Europe doing fantastic research, which is brilliant, by the way. But here, again, wind energy is a developed technology, and this is how we are selling it, so that people are convinced that this is a good thing. But now we are trying to upscale exponentially. And this is why we need this investment, and somehow we need to advocate for it. So we should secure it. We should see more money going into research for wind energy. Because in deep wind, in previous reports, we have seen, and please correct me if I'm wrong, if you have the figure in your mind, that there is much more money going into conventional energy, research for conventional energy, including coal, than it goes to wind. I mean, this is a paradox, let's say. Let's be politically correct, as you said earlier.
Coal anymore, so we stop coal energy.
Yeah, but it came back. Coal came back in many countries in Europe over the last 24 months.
It is true that one of the main messages on the upcoming ETIP Wind new research and innovation agenda, we did the math, and we are asking to triple the investments in research and innovation for the course of the next 3 years. So, fingers crossed. I'm repeating this many times. 3 times more money for the next 3 years.
Because it is not for developing the unit, it is for developing the plant. And I think this is something that we need to make it very clear. Okay, we know how to develop new blades. If you give the specification, we'll have a blade. We can increase the length of the blade, we can make fantastic generators, but going from a unit to a farm, it's a different beast, as we say. And also, I think from universities, just to criticize our side a bit, we also need to be pragmatic in some elements, because there are certain points in R&D where the original equipment manufacturers are doing amazing things. And we need to also listen to what their approach is. And we need to be much, much closer.
Alessandro and Andreas, any final comments on the previous question or a final
Basically,
note?
most have been said. So from my point of view, let's see, of course, this point I basically agree with them. So I would put a little space even for frontier research more, especially into something that will be also tackled by Float Farm. So an eco-conscious design. So since we are developing a somehow new technology, we can also use a different approach in developing it. So rather than mitigating detrimental effects, we can design the new technology to be compliant from the very beginning with environmental constraints. And this is somehow a new way of approaching the design. And I would say that probably some additional funding to this could be useful, because let's say world has changed. So we have learned how to deal with that, and so to me it's very beneficial to include in the very beginning of the design phase.
Andreas?
A big topic is who do you actually sell the electricity to? If you go back to the Hywind Tampen, the largest floating offshore installation today, the electricity is supplied to oil and gas platforms to decarbonize them. The green credentials of that are questionable, and the public is becoming aware of that. So what do you do with the electricity? Do you sell it to industrial end users? Do you sell it to the market? Or how do you design the PPAs? Do you link them to inflation and so on and so on? I think it's a big discussion as well. But yeah.
It is indeed, because as I mentioned also earlier, we're not scaling up without a certainty that their market will be there. So in this case, it's the consumer, and enabling, for example, the corporate PPAs so that it's ensured that someone is going to use the electricity of the wind farm is key as well. My final comment was just an answer quickly to Navid on that. It is true that it's a challenge to, let's say, scale up so much the supply chain, but this is also a part that the Net Zero Industry Act will luckily cover, not only by saying we need to meet this amount of production, but also by earmarking and making available a lot of money for new manufacturing facilities, particularly for the main components of a wind turbine and also the balance of plant. So we will see this is not only through the European institutions, but even the European Investment Bank is also going to be an important, let's say, stakeholder in this equation. And so we are going to close up and make the room for questions. So now I welcome you to raise your hand and ask a question to our panelists. Come on, don't be shy. I can keep making questions, but I think it would be much nicer to hear from you.
Thanks for the nice panel, and thanks for the very good moderation. One of the main topics where everybody seems to be in agreement is the standardization of floating substructures. The question that I have is how to achieve that. So what can research do, or what, because the incentivized structure is, or you need to incentivize several companies that now have started to build expertise on their own specific design to maybe change that and start to do research, or universities need to do research on other designs that until that point they maybe haven't focused on by then. So what can be done to get to that point where everybody is pulling in the same direction?
I think the market will do it. Yeah. That's what happened with oil and gas.
You do have to use the mic because there are people online too. Okay. Don't forget about them, please.
So the market did that for oil and gas. So the cheaper and the better will survive. It's like Darwin law. So I don't think the universities can do too much on this. I think it's the market. But to have a lot of them, it's good. But I see also people reinventing the wheel. You know, I mean, a lot of these structures I have seen, it's like exactly like some structures that was done like 30 years ago. I think we forget what our ancestors did. But the market will do that. Maybe it's too slow, of course. But I don't think the university should do that. The university should be shooting all around and trying new things. This is not for universities. That's for the industries to choose the right ones that make money and are cheaper. I don't know if somebody wants to say something.
Any other reaction?
But still, I think that whenever possible, we could be a bit more directive. Because otherwise, we will keep on working in parallel. Because here, even if we choose 4, let's say, out of the 5 best concepts, and we start focusing on them, we will achieve to make them better, to optimize them. I mean, if we had 20 years of research in vertical axial wind turbine, I'm pretty sure that this would be much better than it was 40 years ago. But we took an executive decision that this is the only way of going ahead. So I think it is a bit of both. I mean, and again, from research councils, maybe we should be split into the blue sky concepts, the concepts that are very low TRL, and focus. I mean, we need a bit of these disruptive technologies, okay? It could be in a controlled way, but we also need to focus on specific concepts. And maybe, by the way, classification could be a more appropriate way than standardization.
Which one, sorry?
Classification.
Classification.
Which is what we do in ship structures.
Consolidation?
Classification means something specific.
Okay, perfect. Any other question in the room? Yes? Please introduce yourself.
Yeah, my name is Francesco Papi from the University of Florence. Yeah, thank you for the great discussion. One thing that was also mentioned was social acceptance, or say social perceptance of the technology. So is there something that you think we can do as universities, as say stakeholders in this process to kind of favor education, favor acceptance? Is there something that we are doing? Can we do more? Yeah, what are your views on this, basically?
Sorry if I could start, again, wearing my other hat as leading the activities of the European Academy of Wind Energy. Social acceptance is proportional to education. And within the Academy, we are doing a fair amount of initiatives. We are trying to train people even before they turn 10 years old, because this will make a very, very big difference. And we see that countries who favor education from very young ages, from a very young age compared to others who do not prioritize this in the curriculum, there is a very big difference in social acceptance. So this is why earlier I talked about perceived impact and actual impact. And the perception of people, especially in social impact, is extremely important, because people do not accept something that they don't know, something that they are not confident about. And this is why we are in a university, and we should advocate about education related to climate change and climate change solutions across all disciplines, not just in engineering.
Navid, you wanted to make a comment?
Yeah, so as university, of course, we are also responsible for educating students, new engineers for future wind turbine designs. And at our university, we have at the bachelor's level lectures on basic wind energy, and there are about 150 students participating. And I have, together with Robert, also a lecture on design and simulation of wind turbines using Q-Blade, and we have some of the students also participating in this room now. So I think that's an important contribution to, to connect young people and future engineers to ongoing research approaches also, and to put them into the, to give them capacities to really design also wind turbines, and to see how nice the task and challenging engineering topic this is. So I think we're doing there a good job, and of course it could be more. But yeah, there are also other topics like electrical cars, vehicles, which are also very attractive.
Hi again, it's Robert from TU Berlin. Maybe to add to this point and to see maybe if you agree with the social acceptance. During my stay at DTU, and that's probably the great thing about DTU, that the wind energy department is so huge that they even have researchers working on fields like social acceptance of wind energy. Your colleague said that in the early days of wind energy, the acceptance was much higher because communities and villages had a stake in the developed projects that were upon to be connected to the grid. And with the developing technology, the projects became much bigger and bigger and bigger, and then they were closed down to public stakeholders. And that's where there was an inflection point where all of a sudden you personally didn't really feel a benefit, but to your, like, at least on your surrounding changed, maybe to the worse. So maybe an open question is there a way to incentivize or make the public domain be a stakeholder in these huge projects that with floating offshore wind will be even bigger than in the past?
For floating offshore, it's going to be difficult because installing in the sea is so big parts. For example, in Italy, I told you that refusals are a big problem, so social acceptance is key. And we as a university are working with the company, and they are used to do what you are mentioning. So they make the population of the villages affected by the wind farm being part of being stakeholders. And this works in the sense that these communities really love wind. But again, the problem of visual impact and this, you will always find someone against. So what I teach in a master science course, which is called Mechanical Engineering for Sustainability. So the first lesson of each of my courses, I always say is to my students that, let's say, energy transition is not an option. So we cannot decide if, we only decide how to do it, okay? So if we want to make energy transition in a reasonable, not good way, so we are not on time anymore to do it fast, but if we want to do it in a reasonable way, we have to install wind turbines, and we have to install a lot of wind turbines. So if you make a rough count, this means that our sons must live in a world where wind turbines are normal. So we have a common good friend of ours, a German professor, that says that in Germany, young boys and girls were born in a landscape with wind turbines. So they cannot even conceive a world without them. And this applies to other renewables. So it does not make sense not to have a world without PV panels anymore, because they are part of our life. And this should happen also to wind turbines as soon as possible, because we basically need this energy. Otherwise, we're not going to meet the goal. So
I think in case of offshore wind is a little bit different than onshore. Huh? Onshore, yeah, exactly. So I'm going to say, onshore wind is in our backyard. We see it every day. Offshore wind, you don't see it. I mean, even in Portugal, they're going to put so far, you don't see really, you see maybe the ships more than the offshore wind. The problem, the social aware, is not the common Joe, it's not the common people, but the people that earn money with the sea. So the fishermen, the environmentalists, they are a big part, and they have to be engaged in the projects. Like you said, if you are engaged, everybody gives their opinion, everybody's happy, because they made part of the decision. So these guys have to be involved in the projects, and if we don't involve the environmental people and the fishing or the fishermen or the people that live out of the sea in these projects, then we'll have struggles, and they pass their negative feelings or the so-called negative feelings to the community. But the normal people don't see offshore wind farms as they see in the normal backyard. So it's a little bit different, I would say.
But I would like to make a very simple comment on this. Very, very simple. What is the social acceptance of coal-fired power plants? Because, I mean, coal-fired power plants is a great technology, and it has helped Europe evolve dramatically over the last century. But now we know better. But there is an impact with this type of plants, and there are regions, when you have coal-fired power plants, there are regions who suffer a real environmental impact. So when people have this type of let's say, comments and queries about the technology, we need to think about alternatives. The fact that your house is powered by a coal-fired power plant that you do not see doesn't mean that it does not cause impact. There is impact, and actually there is proven impact. So we all need to realize that we have a personal responsibility as well in order to solve the climate crisis. And this is why I believe that even the university is late. So people need to be educated much sooner. And the German example of being brought up in a region where you see wind turbines every day, okay, it's something normal, I think this is a very good example.
I see in the schools now, my kids, I have a daughter that is 10, is in a basic school. Last year, they did a lot of stuff about renewables. It's a small school in a village of Portugal, but it's by the sea. They have these green school activities, renewable, I mean, the kids are being taught at schools, and I think it's that. It's not in university, it's already when we are young. My daughter is already so aware of climate change like we never were. So I think we are in the good sense if we put it really very early.
They will be better citizens. The next generation will definitely have better citizens than maybe our generations, because they will all be properly educated.
Alessandro, you wanted to make a
I
comment?
fully agree. My daughter just turned 5, and a couple of weeks ago she told me, "Oh, look, this is the symbol of recycling," and I was impressed about that and very happy. So my daughter sees wind turbines pictures from the very beginnings, and she loves them. But the challenge is also to convince people that now have the money. So I'm pretty confident that next generation will be better than us. But we also need to convince the people that now have to decide and to put money into that, which is not always easy. But we are trying our best, at least with this kind of event. So,
triple the investments. I'll keep saying it.
Another easy way for increasing the acceptance is, of course, having created a lot of jobs. I mean, that's probably the easiest way. I mean, Germany is dependent on the car industry. We have like, I don't know, at least 1 million persons who depend. Their job depends on manufacturing cars. If we would have the same number depending on wind energy, that would be very accepted, you know. That's probably the easiest way. What does your life depend on? Your income depends on wind energy, and that again brings us back to the supply chain and the 40 or 50% issue.
No, but I think all of the points that were made are very valid, and I think it's also very clear that those of you who are parents have a strong connection with how important it is to teach these things at an early stage, and how different is the feeling of your kids towards the wind turbine itself than yours or your neighbors. So it is definitely key that we all as advocates and people working in the wind energy sector, I mean, we have a critical understanding, especially those in academia, a very deep understanding of it's not also all fairy tales. I mean, we have also things that are complex to solve, like we are working a lot on the circularity of the turbine, etc. And it is really our duty to advocate and show how, even though there are challenges, it is probably one of our best shots to make the energy transition work, because from all of the technologies available, it is probably the one with the biggest scalability potential. If you look at the size of area that you need to put 1 gigawatt with solar, with 1 gigawatt of wind to have the same production, yeah, it's said visually. So it is really our duty, and luckily, there are a lot of initiatives. There should be even more. I'll just mention briefly, if you are not aware, because in the previous presentation about gender perspective, there was the mentioning of the MATES or MATES project that was mapping in the past all of the skills shortages. And now there is also like a follow-up project of this, which is called FLORES. I just mention it because it is developing resources to teach mainly to secondary and high school about the offshore wind skills, and well, the offshore wind as a whole, what are the main components, and really to create all of these, let's say, to incentivize people to have a positive attitude towards the technology and to perhaps pursue a career in there. So thank you very much. I just want to really ask everyone to help me on applauding our panelists. And I'll just give the floor back to either Ines or Robert to... Thank you. You are dismissed, yes. If you have more questions, you can reach the panelists on the side.
Really a short wrap-up, just to thank everyone for coming today. Thank you as well to the people online that connected to the YouTube. A big thank to the TU Berlin technical support that was giving today. It was really an amazing job. Thank you very much. Thank you to TU Berlin also for welcoming us today. Thank you to Navid, the coordinator, Robert. Thank you to all, and I hope you had a great day. We sure did, and see you soon for Float Farm. Thank you. Bye. There is food as well waiting for you behind the door.